Today's lesson is Chapter 4, Lesson 1, Writing and Graphing Inequalities. The essential question for the lesson is, how can you use a number line to represent solutions of an inequality? And we have 4 vocabulary terms that we'll define as we go through the lesson. The first one is an inequality. Obviously, in order to write and graph inequalities, we have to know what an inequality is. Solution of an inequality, solution set, and graph of an inequality. So we'll learn all of those in this lesson, and we can come back at the end and fill those in. So let's start right here with what an inequality is. We can read the textbook definition here. An inequality is a mathematical sentence that compares expressions. It contains the symbols less than, greater than, less than or equal to, or greater than or equal to. To write an inequality, look for the following phrases to determine where to place the inequality symbol. We'll get to that in just a moment. Let's go back up to the definition. An inequality is a mathematical sentence that compares expressions. I'm going to start off with an equation. We should know what an equation is. That's also a mathematical sentence that says two expressions are equal. For example, x plus 2 is equal to 5. That is an equation, because we have one expression, x plus 2, that we say is equal to a second expression, which is just 5. So there's two expressions, and they are equal to each other, so we use an equal sign. An inequality is a situation where we have two expressions that may not be equal to each other. All right, so let's use the same variables and numbers. X plus 2 is greater than 5 would be an inequality, all right? Or x plus 2 is greater than or equal to 5. So it's kind of, when we did that greater than or equal to there, kind of makes it a little tricky. They can be equal, but they could also not be equal, right? So when we added this greater to than or equal to sign, that little equals bar at the bottom said it could be equal to it. But the one above it here, the one that says greater than, says it could be greater than the 5, not equal to it. Let me rewrite this without that, though. So let's take a look at just this part. X plus 2 is greater than 5. We have an expression, x plus 2, and we have another expression, 5. So we're comparing these two expressions with an inequality symbol. We're saying that in this case, they are not equal. All right, so an inequality compares two expressions, x plus 2 and 5, all right, and says that they are not equal. They might be equal, but they might not be equal as well. All right, so that's what an inequality is talking about. The inequality symbols, let's see if we can move this up. So these are the symbols, which I've already talked about. The less than, I'm going to write these out here. Maybe you want to write them yourselves. The next one would be greater than. All right. This is greater than, I'm sorry, not greater than, less than. Let me go back to that. Sorry. It's a less than or equal to. And this one is greater than or equal to. All right, you should be familiar with these, but if you're not familiar with them, please make sure that you go back and study this little chart here so that you're able to identify these whenever you see them. So again, I guess I didn't really need to write this stuff. It was right here in the table. Sorry. So less than, greater than, less than or equal to, greater than or equal to. But some other common phrases that you might see that mean the same thing as those. Less than might mean the same is fewer than, or also below also means less than. Greater than can also be written as is more than or above. Less than or equal to can also be written as is at most, is no more than, or you might see the word maximum to represent is less than or equal to. And then is greater than or equal to could also be expressed as is at least, is no less than, or as a minimum, okay? as a minimum is the lowest it can be. A maximum is the most it can be. Greater than has to be above something, and less than has to be below something. So this chart, very, very important for you to know these phrases and what they mean. So please make sure you put some time in to understanding those and asking questions whenever you are unsure. All right, so let's look at some examples. Writing an inequality. Remember, we're writing and graphing inequalities in this lesson. So to write an inequality, we're going to take this word phrase and we're going to write a math sentence from this word phrase using inequality symbols and expressions. So keep that in mind. We got to look for the expressions and we have to look for the words that tell us what inequality symbol we need to use. All right. So a number q plus 5 is greater than or equal to negative 7.9. Write this word sentence as an inequality. So what I want to do is identify the expressions that I'm dealing with and the words that tell me the symbol. So a number q plus 5. That right there is telling me an expression. It's telling me some number that we're going to call q plus 5 is an expression. The other expression I see down here is negative 7.9. And then I need to look for the word phrase that tells me the inequality. It says is greater than or equal to. Is greater than or equal to tells me that the symbol looks like this. Because this is a greater than or equal to symbol. How do I know this is a greater than or equal to symbol? The opening on the symbol, right? This is the, I don't know how I can show this, but this is the opening side over here, all right, right in there. The open side always faces the larger or the greater side, okay? And since the q plus 5 is greater, the opening of the symbol has to face the greater side, all right? And the part where the symbol comes to a point over here is always the less than side, okay? So the greater than side is the open side, and the pointed side is the less than side. And we add the equals bar down here because it says it's greater than or equal to. So we have to put that as where. We have to put that in there as well. All right, so that's the symbol we're going to use. Q plus 5 is greater than or equal to negative 7.9. All right, so why don't you go ahead and see if you can do these two on your own. Pause the video for a moment. Go ahead and write these out, and then see, start it back up, and check out, see if you got them correct. All right, so hopefully you've taken care of that. It's time to check your answers. So number 1 says a number x is at most negative 10. So I'm going to go through this and mark up what I've got. One expression is just a number x. The other expression is negative 10. The words that tell me the inequality symbol are is at most. So I have to remember what that means, is at most. Well, let's write this out here. I get a number x is one expression. I get negative 10, and it says the x is at most negative 10. So that means the biggest it can be is negative 10. But it could be smaller than that. The most it can be is negative 10. So when we see the most it can be is negative 10, the open side of our inequality has to face the negative 10 because the negative 10 is going to be the biggest it can be or the greater side. Okay? But it also, when it says at most, it means it could be less than that 10, but it could be equal to that 10. So it has to be x is less than or equal to 10, negative 10. That means the most x can be is negative 10, or it could be less than. Oops, forgot my r over there. And the x is the less than side, but it could also be equal to. All right, number 2, twice a number y is more than negative 5 halves. All right, so here's my one expression, twice a number y. That twice means to multiply by 2 So we're going to multiply that 2 by the variable y. And the other expression is negative 5 halves. And these words is more than refers to twice a number y is more than. All right, so it's saying the 2y is going to be bigger than or more than. So the open side of our, excuse me, of our inequality symbol needs to face the 2y because that's going to be the greater side. And the negative 5 halves is going to be the less than side. Now, it says it's more than. If it's more than, it's not allowed to be equal to it. So we're not going to add the equals bar underneath. More than means it has to be bigger than. Okay. So we'll give you some more practice of that in class. We'll move on to the next part of the lesson. A solution of an inequality is a value that makes the inequality true. An inequality can have more than one solution. The set of all solutions of an inequality is called the solution set. So, for example, I'll write this off to the side here. I could write a simple inequality like x is greater than 5. A solution for this inequality is if I plug in any number that I can plug in for x that makes it true. So let's think about some numbers that might make it true. I could say 6. So let me plug 6 in for x. If 6 is actually greater than 5, then 6 would be a solution for the inequality because it makes the inequality true. If I chose a number like 3 and plugged it in for x, 3 is greater than 5. Well, that's not true. So 3 could not be a solution of the inequality. Let's choose a different number because it says there might be more than one solution. So I'll just choose the number 10 and plug it in for x. 10 is greater than 5. That statement is true, so 10 would be a solution. So when we think about this, when we go back to the original expression, x is greater than 5. That means any number greater than 5 that I plug in there is going to make it true. All right? And if I was to take all of those numbers and put them into one set of numbers, that would be called the solution set. So how do we identify the solution set? We basically write x is greater than 5. That means any number greater than 5 will make this true. So that's what a solution set is. One single number is a solution. All the possible numbers that make it true are the solution set. So let's take a couple examples here. We have the value of x, they say, is negative 2. So that's what we're going to plug in for x. And here's our expression, x plus 2. And this is our inequality. X plus 2 is less than or equal to negative 1. So what we want to do is plug in negative 2 for x, which they've done here. Negative 2 plus 2 equals 0, which is right there. 0 is not less than or equal to negative 1. In fact, 0 is bigger than negative 1. So negative 2 cannot be a solution because the inequality is not true. Okay? Next one, negative 3. We're going to try to plug that in. Negative 3 plus 2. We add those together and we get negative 1. Negative 1 is less than or equal to negative 1. Because it says less than or equal to, it's allowed to be equal. Negative 1 is equal to negative 1, so that makes negative 1, it makes the inequality true, which means negative 1 is a solution to the inequality. And then the last one, negative 4. Negative 4 we plug in. Negative 4 plus 2 equals negative 2. Is negative 2 less than or equal to negative 1? Yes, it is. It's less than negative 1. So that makes negative 4 a solution to the inequality x plus 2 is less than or equal to negative 1. All right. Checking solutions. So if we're given a problem and we need to check for solutions, all we need to do is plug in the number that they're asking about in for the variable and see if it makes the inequality true. So they're asking us, tell whether negative 2 is a solution of each inequality. So all I'm going to do is plug negative 2 in for the variable. So I'm going to put negative 2 in for the y, minus 5 is greater than or equal to negative 6. All right. Then I'm going to simplify this side. Negative 2 minus 5 is negative 7. Is greater than or equal to negative 6. And now I'm going to check and see if this is true. Negative 7 greater than or equal to negative 6. Well, negative 7 is actually further to the left on the number line than negative 6, which means it's actually smaller than negative 6. So this is not true, which means negative 2 is not a solution for this inequality, y minus 5 greater than or equal to negative 6. So not a solution because it did not make it true. All right, let's try part B. I have negative 5.5y is less than 14. So I'm going to plug in negative 2 for the y. Remember to put it in parentheses. It means multiply here. So negative 5.5 times negative 2 is less than 14. Well, what I'm going to look at here is I have a negative times a negative. Automatically, the rules for multiplying negatives tells me that my answer is going to be positive. And then I'm going to go ahead and multiply 5.5 times the 2. 2 times 5 is 10. Carry the 1. 2 times 5 is 10 again. Plus the 1 is 11. I have one decimal place value to the right of the decimal, so I'll put that in here. So 5.5 times 2 is 11, and I'm going to get 11 is less than 14. And is that true? Positive 11 is less than 14? Yes, that is true. So that means, yes, negative 2 is a solution for the inequality negative 5.5y is less than 14. All right, so there's 3 problems here that you can do on your own. So go ahead and pause the video, come back in a couple of minutes when you're done, and check your solutions. Okay, hopefully you've taken care of that, and you're not just going with the video to get this stuff written down, because remember, you are practicing to get better at this. So let's take a look at this. Tell whether negative 5 is a solution of the inequality. So I'm going to go ahead and plug in negative 5 for the variable. And I get negative 5 plus 12. I simplify that, I get a positive 7. Is 7 greater than 7? No, 7 is equal to 7. So negative 5 is not a solution for this inequality. Did not make it true. Let's look at the second, number 4. 1 minus 2p is less than or equal to negative 9. I'm going to plug in the negative 5 for p. Remember to put it in parentheses. And I'm going to look at this. I have to do order of operations, and I have a multiplication right here to do first. So I have to keep the 1 minus. 2 times negative 5 is negative 10. A positive times a negative is a negative. It's less than or equal to negative 9. And now I've got a keep, change, opposite subtraction situation here because it's not normal. So I'm going to have a 1 plus a positive 10 is less than or equal to negative 9. And 1 plus 10 is 11, less than or equal to negative 9. And 11 is not less than or equal to negative 9, so negative 5 is not a solution to this inequality. And then the last one, it says n divided by, this is a divided by symbol, n divided by 2.5 is greater than or equal to negative 3. So I'm going to plug in negative 5 for n divided by 2.5 is greater than or equal to negative 3. Negative 5 divided by 2.5 is negative 2, greater than or equal to negative 3. Negative 2 on a number line would actually be, here be negative 3, negative 2 would be to the right, 0 would be up there. Negative 2 being to the right of negative 3 means it is greater than negative 3. So this is true, which makes negative 5 is a solution to this inequality. All right, again, ask questions in class if you're not sure of what's going on there. The last thing we need to do is the graphing of an inequality. The graph of an inequality shows all the solutions of the inequality. So it shows the solution set. When they say all the solutions, that means it's going to show the set of solutions. of the inequality, and it shows it on a number line. When we make this graph, an open-ended circle, an open circle is used when the number that we're starting our number line at is not part of the solution, okay? A closed circle is used when the number that we're talking about being the solution, the number where we're starting our number line, is part of the solution. So it is part of the solution. And then an arrow to the left or right shows the direction where all the other solutions would be found. So let's go ahead and take a look at this problem right here. And then I'll probably do another one next to it so that you can see another one. So graph y is greater than -8. So what I need you to do is write a number line first. Let's put 0 on here somewhere. And let's figure out where -8 would be. So if I think about it, -1, -2, -3, -4, -5, -6, -7, -8 would be all the way over here. All right? Maybe there'd be a 1 and a 2 and a 3 up here. So 1, 2, 3, -1. I'm not going to put them all in. There'd be -3 here, -5 right here, and down here is -8. Now it says y is greater than -8. It does not say that y can be equal to -8. So this is where we have to use an open circle at -8. This number is the starting point of our graph. So we're going to circle where -8 is. And I like to draw it a little bit above the number line so that we can actually then make our arrow and be able to see where it is. So that circle that I just drew is the starting point. It's saying we're starting at -8, but -8 is not a solution. And it says y is greater than -8. Well, on a number line, greater than is anything to the right. I'm going to redraw the circle in blue so maybe you can see a little better. So that's at -8. And then to the right, anything greater than -8 is part of the solution set. So if I pick any number to the right of -8 and plug it into the inequality, it will make it true. All right? I'm going to draw another one over here. I'm going to have your graph. All right? X is less than or equal to 4. Okay? So I do the same thing. I draw a number line. And I'm going to locate a 0 on here. I always got to have a 0 on there because that's a reference point to know where other numbers need to go. To the left of 0, I might have a -1. To the right of 0, I've got a 1, a 2, a 3, a 4, maybe a 5. Okay? But I know that I don't need to go more than 4 because that's my starting point. My starting point of this graph is going to be at that number 4. All right? Now, I look at the inequality symbol right here, and it tells me that x is going to be less than or equal to that 4. If it can be equal, do it in blue again. If it's allowed to be equal to, that means 4 is part of the solution. So that means at 4, I'm going to put a solid dot because the solid part tells me the number 4 is part of a solution. It makes it true. And then it says all the solutions that make it true, all these x's are going to be less than or equal to that 4. We already did equal by filling in the dot. Less than means to the left on a number line. So we would graph it like that. Any number to the left of 4 and the number 4 make this inequality true. All right? So everything that's in the blue arrow, any number to the left of 4 and 4 will make it true. All right? I think we've got some on your owns here. We've got 4 problems there that you guys can do on your own. So go ahead and pause the video, do these 4 problems, and then restart the video to check your solutions. Okay, hopefully you've done what you're supposed to do there. So our first example, number 6, x is less than -1. The -1 is our starting point. So let's put a 0 here and a -1 there. All right? We can put some other numbers on this side, 1, 2, 3, and 4. And it says x is less than -1. So less than means not equal to. So I'm going to put an open circle on the -1, all right, because that's our starting point. And all the numbers that make it true, the x values, are less than the negative 1, that means less than goes to the left. And that would be our graph. All right, so that's number 6 right here. Let's do number 7 right here. Z is greater than or equal to 4. So I'll put a 0 here, a 1, a 2, a 3, and a 4. Now 4 is my starting point. Okay, 4 is the starting point. And all the solutions that make it true are greater than or equal to 4. So that means I'm going to put a closed circle on the 4. And all the solutions are greater than or equal to, so greater than means they're going to the right. Bigger than. All the numbers to the right of 4 are bigger than 4. And 4 also makes it true. All right. Number 8 down here. S is less than or equal to 1.4. All right, so this might be a little difficult to do a 0 on here, but what I really look for is something like this. Let's say I just have 0 here. 1.4 is positive. All positive numbers are to the right of 0. So I'm just going to pick one of these tick marks and label it 1.4. Okay? And then I'm going to look at this and say the inequality symbol, the 1.4 is my starting point. The inequality symbol is a less than or equal to. So that means 1.4 is part of the solution. So I'm going to put a closed circle right above the 1.4. And it also says that S can be less than 1.4. So that means it can go to the left where the less than numbers are. All right, and then the last one, we have negative 1/2 is less than t. And this is kind of tricky because now they have the variable on the other side of the inequality. So my recommendation for this is always read the inequality starting with the variable and then read towards the number. So I'm going to read it this direction. And when I do that, I say, okay, t is the variable. The symbol I'm looking at is greater than. So t is greater than because the t is next to the open side. The open side is the greater side. So that makes t greater. The negative 1/2 is on the less than side, all right, the pointed side. So I'm going to read from the variable. It's going to be t is greater than negative 1/2. All right, so I'm going to pick up any one of these tick marks to make 0. Negative numbers are to the left, so I'm going to make negative 1/2 down here at this tick mark. All right, now let's read it again. T is greater than negative 1/2. Greater than doesn't mean equal to, so that means I have to have an open circle at negative 1/2. That's my starting point. And t is greater than negative 1/2. Greater than goes to the right. If you always read your inequality starting with the variable, it will make it easier to graph because it will always tell you if you're greater than or less than when you read it that way. T was greater than negative 1/2. Greater than is always to the right on the number line. Okay? All right, so there are some problems right here that I'm going to ask you to do some of these to make sure that you understand what's going on, and then you can turn these into me in class. Okay? So here's what I'd like you to do. I'd like you to do number 3. I'd like you to do number 5. I'd like you to do number 7. I'd like you to do number 9. And I think I'd like you to do number 10. Okay? So let's do those 5 questions to make sure that you understand what's going on here. And turn those into me. And if you have any questions, please make sure that you ask questions when you get into class.